Today we are going to start our similarity transformation, which is dilations. A dilation is a transformation that produces an image that is the same shape as the original, but is not the same size. A dilation is similar to the original figure. We have been working with transformations such as translations, reflections, and rotations, where the pre-image is congruent to the image. But here, because we have a similarity transformation, our pre-image is similar to the dilations image. Dilations are centered around the origin, unless otherwise stated. Scale factor is a ratio. The image length divided by the pre-image length. And the scale factor is the ratio we will use to perform our dilation. In enlargement, if the scale factor is greater than 1, the figure becomes larger. As you can see, with a scale factor of 2, the pre-image is smaller than the image. The triangle gets larger. A reduction, if the scale factor is between 0 and 1, the figure becomes smaller. And as you can see, with the scale factor of 1/2, a fraction between 0 and 1, the pre-image is larger than the image. The dilation caused the triangle to become smaller. The general rule for a dilation, x comma y, goes to k times x, comma k times y, where k is the scale factor. So whenever we are given a scale factor to write our rule, we're just going to replace k with the scale factor. Example 1, write the general rule for the dilation given the scale factor, and then state if the dilation is an enlargement or a reduction. So for A, we have a scale factor of 3. So what we're going to do here, we always start our rule with x comma y arrow, and we're just going to replace k with 3 because 3 is our scale factor. So we have 3x comma 3y. Because our scale factor is greater than 1, we will have an enlargement here. Please pause the video and try B and C on your own. For B, we have a scale factor of 1/4. So our rule is going to be x comma y arrow 1/4 x comma 1/4 y. Because 1/4 is between 0 and 1, it is a fraction, we will have a reduction in B. And for C, we have x comma y arrow 5/2 x comma 5/2 y. Now C can be tricky. Just because 5/2 is a fraction does not mean it is between 0 and 1. If we divide 5 by 2, we get 2.5. 2.5 is greater than 1, so we know we have an enlargement here in C. For example 2, triangle ABC has vertices A 0, 2, B 4, 4, and C -1, 4. What are the vertices of the image with a scale factor of 4? So for A, we are going to use the rule x comma y arrow 4x comma 4y. And all we're going to do here is multiply both our x and y coordinates by 5 to find the vertices of our image. So for A prime, we have 0 times 4, which is 0, and 2 times 4, which is 8. For B prime, we have 4 times 4, which is 16, and 4 times 4 again, 16. And C prime, we have -1 times 4 is -4, and 4 times 4 is 16. Pause the video and try B on your own. For B, we are going to use the rule x comma y arrow 1/4 x comma 1/4 y. So here all we are going to do is multiply both of our x and y coordinates by 1/4. Remember, multiplying by 1/4 is the same as dividing by 4. So for A prime, 0 times 1/4 is 0. 2 times 1/4 is 2 over 4, which reduces to 1/2. B prime, 4 times 1/4 is 1, and 4 times 1/4 again is 1. And for C prime, -1 times 1/4 is -1/4, and 4 times 1/4 is 1. For 3, quadrilateral A prime, B prime, C prime, D prime is a dilation of the quadrilateral ABCD. Find the scale factor and then classify the dilation as an enlargement or a reduction. So to find the scale factor here, we want to list out the coordinates of our pre-image and the coordinates of our image. So for A, we have 6, 0. B, we have 0, 6. C, we have -6, 0. And D, we have 0, -6. Now we want to list out the coordinates of our image. A prime is 2, 0. B prime is 0, 2. C prime is -2, 0. And D prime is 0, -2. Now to find our scale factor, we want to see what we had to multiply the coordinates in our pre-image by to get the coordinates in our image. So to get from 6 to 2, we multiplied by 1/3 or divided by 3. Same thing again, to get from 6 to 2, we multiplied by 1/3. -6 to -2, we multiplied by 1/3. And -6 to 2, we again multiplied by -1/3. So we know our scale factor for this dilation is 1/3. Because our scale factor is 1/3, which is between 0 and 1, we know this dilation was a reduction. Quadrilateral PQRS has vertices P -2, 4, Q 4, 4, R 4, -2, and S -4, -4. It is dilated by a scale factor of 1/2. What are the coordinates of the image? Graph both the pre-image and image. So let's start by graphing our pre-image, quadrilateral PQRS. We have -2, 4, 4, 4, 4, -2, and -4, -4. All right, so now we have to find the coordinates of our image. To find the coordinates of our image, we are just going to multiply our x and y coordinates by 1/2 because 1/2 is our scale factor. -2 times 1/2 is -1. 4 times 1/2 is 2. For Q prime, 4 times 1/2 is 2, and 4 times 1/2 again is 2. For R prime, 4 times 1/2 is 2. -2 times 1/2 is -1. And for S prime, -4 times 1/2 is -2, and -4 times 1/2 again is -2. Now we can plot our image. So we have -1, 2 for P prime, 2, 2 for Q prime, 2, -1 for R prime, and -2, -2 for S prime. As we can see, because our scale factor was between 0 and 1 and our image got smaller than our pre-image, we do have a reduction here. In part B, we want to demonstrate that these quadrilaterals are similar, that this is a similarity transformation by comparing the ratios of the lengths. Again, remember the ratios of the lengths should be equal to the scale factor. Our scale factor was 1/2, so the ratio between our lengths should also be 1/2. For PQ, the length of PQ, because it is a horizontal line, we can just count it on the graph. So the length of PQ is 6 units. And the length of P prime Q prime is 3 units. Now, if you recall, our scale factor is always our image length divided by our pre-image length. So here, if we do 3 units divided by 6 units, we get 1/2, which is the same as our scale factor. For the length of QR, we also have 6 units. We can count again because it's a vertical line. And for the length of Q prime R prime, we have 3 units. So again, if we divide 3 by 6, we get 1/2, which is equal to our scale factor. Now for PS, P prime, S prime, SR, and S prime, R prime, because they are diagonals, we have to use the distance formula this time. So if you recall, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So to find the length of PS, we have the square root of -4 minus -2 squared plus -4 minus 4 squared, which simplifies to the square root of 68, which simplifies further to 2 times the square root of 17. To save time, I'm just going to give you the lengths of the rest of the lengths here. So if we use the distance formula to find the length between P prime and S prime, we would get the square root of 17. For the length of SR, we would get 2 times the square root of 17. And for the length of SR, we would get the square root of 17. So as you can see, for the length of PS and the length of P prime S prime, again, if we divided the image length by the pre-image length, we would get our scale factor of 1/2. Same thing for the length of SR and the length of S prime R prime. Because we got the scale factor when we divided our image length by our pre-image length, it proves that the two figures, the image and the pre-image, are similar figures. Please pause the video and try example 5 on your own. Triangle XYZ is graphed below. Draw and label the triangle X prime, Y prime, Z prime after a dilation using a scale factor of 2. So what we're going to do first here is list out our coordinates of X, Y, and Z. X is -1, -1, Y is -1, 2, and Z is 1, 1. Now to find the coordinates of our image, we are going to multiply both our X and Y coordinates by 2 because our scale factor is 2. So for X prime, we have -2, -2. For Y prime, we have -2, 4. And for Z prime, we have 2, 2. Now that we have the coordinates of our image, we can plot our coordinates. We have -2, -2 for X prime, -2, 4 for Y prime, and 2, 2 for Z prime. We can connect our points. And we can see because our scale factor was greater than 1, we do have an enlargement here. Our image is bigger than our pre-image.